Okay, so in this question, we've been asked to, we've got Na₂SO₄, right? So sodium sulfate, and we've in effect been asked to work out the value of X, right? Now, in this particular case, the value of X, we can effectively deduce that what we're really being asked is for every 1 mole of Na₂SO₄, how many moles of H2O would be present in that given hydrated sample, right? So, you know, one of the more straightforward ways of working this out is we need to convert some of these masses we have into amounts of substance so we can compare them more easily. In other words, we need to convert them to moles, right? So in this particular case, we've got the anhydrous mass of the sodium sulfate here, right? So what I'm going to do is I'm going to work on converting that into a molar value, right? So what I'm going to use is that the number of moles N is equal to mass M divided by molar mass MR, right? So in this case, I'm saying that, well, the number of moles for Na₂SO₄ is going to be, well, the mass M, which is 2.98 in this case, right? So that's the anhydrous mass divided by the molar mass. Now the molar mass, we can work this out from the periodic table. So Na₂SO₄, so MR of Na₂SO₄ is going to be effectively, well, 23, right? So 23 times 2 plus SO, that's going to be 32.1 plus 0.4, right? So that's going to be effectively 4 times 16, right? And so that's going to give us the molar mass for the Na₂SO₄, and that's going to be 142.1. That's going to be in grams per mole, okay? Right. So, yeah, so here we put 142.1, right? Now, the other thing we need to deal with is, well, before you go into that, let's actually work out what this is. So if you have a go, you should find that gets you to 0.02091, right? And that's going to be in moles, right? So I've just given that, just kind of, you know, that's the five significant figures. What you want to also do is work out the number of moles for the H2O, right? So the number of moles for H2O is going to be, well, for this we need the mass, right? So we don't actually have the mass explicitly given, but what we do have is the hydrated sample mass and the anhydrous sample mass. So the difference between the two is, of course, due to the loss of H2O. So therefore, to work out the H2O, we can just do, well, 4.06 minus 2.98, right? Which is equal to 1.08, right? And that's going to be in grams, right? So therefore, for the number of moles, using the same formula again, we're going to have simply 1.08. Then we also need to divide that by the molar mass of H2O. So in this case, for H2O, it's going to be 1 times 2, right? So that's for the hydrogen aspect, H2 plus the relative atomic mass of oxygen, which is going to be 16, right? And there's only going to be one of that. So say MR of H2O is going to be that, and then which is going to give us 18, right? And that's going to be grams per mole, right? Okay, so that's going to be 18 divided by 18. So if you do have a go at working that out, you should find that that gives 0.06. That's going to be moles. Okay. Now, one of the things I'm going to do at this stage is remind myself of, well, what is this? What are we trying to work out? We're trying to work out for every 1 mole of Na₂SO₄, approximately, when we look at it as an integer value, how many moles of H2O are we going to have as well? So what I want to do is I'm going to put a side-by-side comparison, and in the formula, the Na₂SO₄ is on the left-hand side, so I'm going to do that as well in the ratio comparison. So Na₂SO₄, and then comparing that to the moles of H2O. So H2O. So for the left-hand side, we work this out. It's here, right? So that's going to be 0.020971, right? And that's in ratio of the H2O, which we worked out as well here. So 0.06, right? Now, as I said, this is the real framework we're thinking about when we're thinking, okay, what's the value of X? Is for every 1 mole of Na₂SO₄, what's going to be the moles of H2O? So we really want to get this value on the left-hand side to be 1 because of that. And, you know, the straightforward way to do that is to divide it by itself, right? So divide that, and that's going to give us, so we do that, and then that's going to give us 1, okay, because we're dividing by itself. But what we need to do, because we've divided, because we've done that on the left hand side, we also need to do the same on the right hand side. So we need to divide this by the same number, because it's a ratio. So 0.020971, right? And when you do that, what you're going to get is 2.8611, right? Now, one of the things we need to actually do here is we're looking for an integer value. So 2.8611 is not an integer value, so we need to round that to the closest integer value, which in this case means we need to round it up. All right, so, and that would be rounding it up to a value of 3. Okay, so therefore what we're going to say here is that the 1 is in the ratio of approximately 3. Okay, and therefore X is equal to 3. Okay, and therefore what we have in our formula is Na₂SO₄ 3H2O, right? So, you know, in effect, that's what we get. And so up here in our, you know, the question that we've got here says, please enter your answer in the space provided. We can say, well, H2O, the coefficient is going to be 3. What does that mean? Well, that means for every 1 mole of Na₂SO₄, our working has led us to the conclusion that you're going to get 3 moles of H2O, right? Yeah. Okay. Yeah. So that's